Welcome to Factorio. Today I'm going to talk about my Combinator Ethernet system, which is this set of 4 blueprints right here, why you might use these and how to use them, and a little bit of how they work. The basic idea is that these blueprints let you transmit many different signals on circuit wires through just a single wire that runs across your whole base. So you might run this along your train tracks, and the idea is that it's a little annoying to try and run new wires all the way across your base if you have something new that you want to hook up, some new system you want to run. But if you already have a wire running everywhere, it's nice and easy. The problem is that sometimes one wire isn't enough if you're just adding new things on. So for example, up here, I have a coal mine and I'm looking at how much coal is left in that mine. But I'm also looking at how much coal is passing through this belt here, and that's also a coal signal on a red wire, and if I combine them, then both of the values will be wrong, basically. So Combinator Ethernet solves this for us, and we have 4 different blueprints, 2 transmitters, 2 receivers, and there's a level mode and a pulse mode. All of these are compatible with the same network, so you can run all 4 of these together. As a simple little example, here I have some circuits that are flowing through, and I might want to measure somewhere else how many circuits are flowing through or how often. And so I've got a pulse reader here on this belt, and that's going onto this red wire, so you can see those little pulses. So I'm going to set up a pulse transmitter for that at first, and the pulse transmitter has a power pole, and all of the power poles, it's a little hard to see, but all of the power poles in these blueprints have both a green and a red wire. In the Combinator Ethernet system, the green wire is the network wire. So you're going to want to hook up that power pole to some set that has your green wire spanning your whole base. And then the red wire is your local data wire. So you're going to want to hook that up to your source here. And immediately you can see it starts transmitting. That green flash there indicates successful transmission. And over the wire, you can see there are some signals. There's a little more than just the chips on there, though. There's some control signals. So there's a black signal, which indicates that there is a transmission, and that's used for collision avoidance. And there's also this gray signal, which is the destination address. And so we set that to 500, then our gray signal that's being sent with each frame will also update. And we can read these signals out using a pulse receiver, which has a similar setup, just a little smaller, where the green wire is the network. And once we've done that, we can look at the value on the red wire here, and we can see that, well, I didn't update the signal there. So that's a little sneak preview of a feature, but the address here is 500, and now we can see this is receiving, and this is coming through with those chips. So when we had this back here at gray as just 5, of course, none of the signals were coming through because this is essentially just a filter to see when I have the right conditions on the wire. I want to send that pulse right on through. So it is important to have these signals matching up, which is a feature. That means that we can send different signals over the same wire without them colliding. So here I've got a coal pulse that I'm monitoring from this belt up here as coal is flowing through. And that's over here as well. And so I can set up another pulse transmitter and run that here. Again, I want to hook up my red wire, and that's going to start pulsing there. I want to change this channel to 501, and I want to hook up my green signal wire to my global network to make sure that everywhere I go, I can access all of my signals. Something you might notice is that now every so often the bulb here is flashing yellow instead of green, and that means that it's detected a collision. But every time it flashes green, that's a successful transmission, and usually after collision, transmission succeeds right away anyway. And so then again over here, we can set up a pulse receiver once again, this time set the channel to 501. Usually it's best to set the channel before hooking anything up. And then look at the red wire contents. And here we've got coal pulsing through here, and we've got circuits pulsing there, and these signals are separated just by the address that's going over the wire. You might see sometimes there's the red signal going through there, and that's collision detection and avoidance happening. These two are keeping track of unique identifiers between the two of them in order to avoid transmitting at the same time. They each wait sort of a unique delay between them. There's a link that I'll put in the description that'll show a bit more of how that happens in just a small number of combinators. It's not actually as fancy as it sounds, but it works. It works really well, actually, even with dozens or hundreds of transmitters all transmitting at once, these things will just gracefully kind of slow down just a little bit, and you'll still get plenty of bandwidth through the system. We can add more and more, but I want to show a level transmitter since that's another one of the types here. So we use level transmitters, or you might think of them as state transmitters or value transmitters, in a scenario where we're trying to send some not constant, but some fixed value, or some, I guess, changing value, but something that's not a pulse, something that's rather just a value that's held. So here we've got a coal mine, and we're looking at how much is in that mine. This value will very slowly go down as we mine this out, and that's going to this wire here. And if we want to update our base with that value, we can use a level transmitter. So a level transmitter looks almost the same. We still have the gray address combinator here at the corner, and we've still got this pole here that has the signal, or excuse me, the network wire here in green. So we're going to hook that up to our network. And then we also have the red here, which is going to receive our actual data. And so if we hook that up, we'll see that this every so often will transmit. It transmitted at first when we hooked up, and anytime this value changes, which I guess is really slow for some reason, this is going to blink again and update. There you go. So that just went again. I wonder why this mine is so slow, though. This actually... interesting. I don't know. I haven't really played around with the mines too much to understand how that works, but all of that information is now in this wire, and if we used a pulse receiver, that wouldn't really work so well because we would just get a pulse that tells us every so often that there's some value there, but we want to be able to just always read it. So if we hook this up again to our network wire and we set our address to 503, I think it was, or was it 502? I think it was 502. We'll see. Then we can connect our red wire. And if we received a pulse, there we go. This is going to keep the last value that was received. So anytime that we send a new value for coal there, it's going to update this little memory cell, whichever one it is here, this one. And that's going to expose that new value. So all of these can be combined onto a pretty large network. And I've done that in my base. So down here, I have my real signal wire. And you can see a bunch of different activity going on, most of this from my power control system, but you can actually get quite a bit of data going through there. So I've got power control, I've got train control. In this case, I've got a power control system that is telling this factory whether to turn on or off based on how much power I have available. And then in other parts of my base, if I go into map mode here, I've got train controllers that are telling the train when it can leave in order to avoid congesting the railway system. So there's a transmitter here and a receiver here, and then a little bit more train logic there. And this is all just on the same global wire, one wire that goes everywhere throughout my whole base. I even have more power control logic here, and then a power control computer all the way over here. And so you can see these things can be spread anywhere you want, and that's actually really nice. Yet another one, I think, up here controlling the nuclear power plant, telling it when to load new cells in. So I can actually turn this plant off remotely by just telling it to not load any more cells, or I can go to my nuclear power computer over here and change the total number of nuclear power plants that should be running, which is in fact exactly what the power control circuit does. And so it's here, we can see it's trying to decrease the number of nuclear plants that are running from 21 to 20 at the next clock cycle. So definitely you can do a lot with this system. And for a little bit on how it works, if we look at the signals that are coming through here, I guess we can't get a pause there, and I don't have my my creative mode on, but there is a black signal which is going to be set to 1 anytime we're transmitting. And that way, if we ever have 2 transmitters transmitting at the same time, that black signal will end up being more than 1. And so our receivers will reject that. And they actually look here and we see we've got a -1 here. And so if we ever have, oops, I guess I'm not actually physically there. I need to walk over. If we ever have more than 1 signal or less than 1 black signal, it's going to filter it out. And then similarly, we filter on the gray signal, which is the address of each message that's being sent. So you can kind of see the 503, 501, 502 that's flickering there, and the payload that's also in there. So In general, when using this system, try to avoid these color signals because these are used for control. There's also the red signal that's used in case of collisions, and you can see that popping up every now and then. You'll probably want to avoid that. But otherwise, this is a relatively easy to use system. You just hook up the green and red. For some very advanced use cases, you might want to hook up onto the lamp as well. The lamp sends either a green signal when we've just completed transmission or a yellow signal if we've had a collision. And the reason you might want to hook up onto this is if you're building some kind of asynchronous circuit where you want to send a pulse and then wait to be sure that transmission is succeeded before you send another pulse. As an example of that, my train control system over here has a transmitter, and we can see here that we've got a wire here connecting to the green signal. If I get a green signal from that, then I'll go and I'll trigger the mechanism to say, go and schedule another train. So here, let's see if I can get this to be visible. If I tell this, right now it hasn't emptied its cargo yet, but if I say, please go pick up more, then that light just blinked green for just a second there because it sent out a pulse to command that train and another train to move along. So hopefully this gives you some ideas on how you might send some wires across the network. One more example I'll show that could be convenient for some bases is for my science system. One problem you can have as you adjust your base, especially if you have such a spaghetti base like this one, is that there's a lot of science waiting on the belts here. And so you might starve your science production of resources and not notice for a really long time. This belt is actually quite long, runs all the way up to here to producing yellow science. And so what I've done here is, if I can find it, here we go. I'm transmitting whether or not this belt is backed up or whether or not there's enough resources here. And so we can see there are 4 yellow packs on this belt. So this says, all right, this is backed up just fine. But suppose I start to drain too much yellow science out of the system. This will actually send a signal that says, and this is a level transmitter, that says, hey, there is not enough yellow science back there on that belt. And then over here, where is it? Here, I will end up actually stopping the belt. And so I'll say, because I've received here that there's not enough yellow science, I'm going to stop the belt there. And that way we don't have these weird buffer effects. It can just very quickly replenish. And I can easily see at a glance whether or not I have enough science just by looking down at my science center here and seeing if these belts are enabled or disabled, or even just look here and see that yes, in fact, I do have enough of all of the sciences, at least for the ones that I've monitored. You can see gray is actually running out, but that's because I don't have a monitor for it because gray science is made just right here. So let me know what you think. If you enjoy using these, or if you have any issues with these, let me know. These are pretty well battle tested, so I haven't run into, with hundreds of hours of using these, haven't run into any issues, but always happy to see any kinds of improvements that are possible for these. Thanks for watching.